Welcome back. Well, with the jump to digital, there's been some technological challenges along the way, especially when it comes to EAS. And if you're a broadcaster and you want to become compliant and you're struggling with that, look no farther than Trilithic, and I'm here with Art. And Art, you have a beautiful solution, really born out of experience. You guys have been around forever. Tell us a little bit about Trilithic.
Well, we started in EAS in about 1995 time frame when the regulations came out of the FCC. We started with analog EAS systems, comprehensive solutions for large broadband networks, and then we developed the actual first digital interface for a company called Scientific Atlanta that everyone knows well as far as digital set-tops, and because cable and broadband has done digital for many, many years. We've transitioned over the last 3 years into some pure digital EAS offerings. In technical lingo, SDI signaling, and a brand new product launched at this show, which works in the transport stream, the ASI transport stream for a broadcast station, which significantly simplifies EAS over MPEG on broadcast television.
And you know, that is really what's been needed. There's a lot of stations out there who are struggling right now. For EAS, have to going back to NTSC and then back to digital, and it's been a nightmare, but this really offers a solution.
Yeah, currently a lot of legacy gear exists in the broadcast station, the broadcast head end, whereby even on their digital transmitters, during just an EAS, a regular EAS message, an amber alert, a tornado warning, the whole facility has to drop back to analog just to get the message on. What we're offering is to remove all of that analog switching mechanism, put it into one single piece of equipment whereby their transport stream can have EAS crawl messages applied with EAS audio replacement in real time over all their .1, .2, .3 services.
Well, Art, let's go take a look at the nuts and bolts of this and how it actually works.
Okay.
All right, now Art, as a guy who spent many years going into the control room, I can understand some of this rack-mounted material that you have here, but tell us about what we have.
Okay, what we're looking at here is this 2U box is the entire EAS system. This is the device that monitors your local radio stations, what are called LP1, LP2, local primary stations. That's where the EAS message comes from. The radios are built in. We also monitor NOAA, the National Weather Service, which is now the All Hazards Network under Department of Homeland Security. This EAS system processes the EAS messaging and now puts it to the proper injection technology. In a DTV studio, a DTV head end, that technology is now compressed video, MPEG-2 type video, several a high def and a standard def, or a couple standard def channels muxed together into a single wire, a single transport stream. It then makes it difficult to get EAS targeted messages onto your network when you're running multiple stations, multiple geographically located transmitters. As the industry progressed to their DTV model, their DTV central cast architecture, they lost the capability, and we'll use some sample cities. Greenville, South Carolina may see an amber alert that's for Charleston, South Carolina, because the infrastructure, the central cast has one particular video source for that channel that goes out everywhere, goes out to all the different cities. With doing EAS overlays, crawl overlays, and audio replacement at the ASI level, I can now park an ASI box or an ASI port for Greenville. I can do one for Myrtle Beach. I can do one for Charleston. And I can take an amber alert that comes from Charleston and send it back to Charleston in that central cast generic type of a model.
So this is just an amazing technology you've brought to bear on this and really solved a lot of problems.
It solves a great deal of problems. The product itself, and what we've done is we've teamed up with RGB, with RGB in the past years doing digital simulcast. Both companies are very familiar with targeting digital EAS messages. So we teamed up with them on a product that they already had called a statistical multiplexer. And if up on the screen or on this screen, you'll see statistical multiplexing this is the high def channel. This is a couple standard defs of the new DTV signal into your television. So in that stat mux, we now have an EAS interface that on each one of these video streams, we can place an EAS crawl on the television, on your digital television, your plasma TV, for instance.
And with RGB, the opportunities and possibilities expand even more. We can do picture-in-picture, we can do a lower 1/4 logo, we can do bugs. So the marriage of the two is just really natural.
Absolutely.
Now, to throw up an EAS message on this, what's involved?
For instance, what we're looking at on this television here is a high-def feed as part of this signal path. I will start a required weekly test. You can see the end result up on the screen. Now, what you'll see, this is direct digital on this television. There are no set tops, there are no converters, and this is the digital crawl that you'll get. High definition crawl, positioned on the screen where it's necessary.
Well, Art, I have to tell you right now, with all that you've mentioned about Trilithic and even your partnership with RGB, I know you have to have the attention of all of our viewers out there wanting to solve the headaches. What's the best way for them to learn more about Trilithic?
Optimally, you can check into our website at www.trilithic.com.
Easy enough. Well, Art, thank you so much for being on.
Thank you very much.